Assalamualaikum warahmatullahi ta'ala wabarakatuh. Today I want to present my Bachelor Degree Project 1 or PSM1. My name is Muhammad Nur Aizat bin Rahmat from Class 3 BEZ, metric number B081810167. I would like to thank to my supervisor that guide me through this project is Madam Izzadura binti Mustafa. And I would like to thank to my panel is Encik Amar Faiz bin Zainal Abidin and TS Dr. Nur Hashimah binti Muhammad Saad. Okay, the title for my project is Development of an IoT-based heart palpitation monitoring for heart disease patient using Arduino. Okay, for project background, the main aim of this project is to propose the type of portable electrocardiogram (ECG) for patient heart palpitation, and it records the electrical activity that show how fast the heart is beating, the rhythm of the heartbeats, either steady or irregular, and the strength or timing the electrical impulse. The heart rate is monitored using real-time sensors such as a heartbeat sensor or an electrocardiogram (ECG) sensor, which are attached to the patient's chest and monitored every second. This project works when interface ECG sensor module AD8232 with Arduino Uno board to get the electrocardiography ECG of a patient on the serial monitor. And by using ESP32 Bluetooth and Wi-Fi board, it can interface with AD8232 to get ECG graph through IoT cloud platform. What is heart palpitations? Palpitation is a symptom that occurs when a person's heart beats abnormally, quickly, or irregularly in their chest, such as skipping beats, fluttering swiftly, beating too fast, hammering, and flip-flopping. You may notice heart palpitation in your chest, throat, and neck. Heart palpitations usually are not serious or harmful, though and often go away on their own. Most of the time, it caused by stress and anxiety or because take too much caffeine, nicotine, or alcohol. And it can also happen to pregnant women. If you have serious heart palpitation, must see the doctor and get immediate medical attention. Okay, for the problem statement, the people who suffer from heart palpitation, in case if there is any change in heart rhythm, it will not have any feel in their body. In the beginning, patients cannot feel the change of her beat, rhythm, and when it goes severe, then it will create a pain and lead to sudden heart attack. The patients who got heart attack, they will be suffer more pain and they will unable to think, and at last it may lead to sudden death. Okay, for the objective for this project is to design a project to facilitate the patient heart palpitation, to read a graph waveform electrocardiograph (ECG). Second, to implement a monitoring system using IoT for patient heart palpitation by prototype and simulation. And lastly, to analyze a system that provides to control heart palpitation. The scope of project is to interface ECG sensor module AD8232 with Arduino Uno board to get electrocardiograph of a patient on the serial plotter. Internet and Bluetooth connection with the help of ESP32 interface with ECG sensor module to send data to IoT platform. Internet of Things platforms such as OBDOTS that enables to capture sensor data and turn it into useful information. Okay, for the part methodology. Okay, for the block diagram. Shown in my slide is from the patient will get the ECG signal from ECG sensor that I use. ECG sensor that I use is AD8232. And then ECG sensor AD8232 will interface with two types of microcontroller. It is Arduino Uno, and ESP32 Wi-Fi. In Arduino Uno, the ECG sensor, the ECG signal or ECG graph will will display in serial plotter. And for the ESP32, with using Wi-Fi, it will send the data of ECG signal to the IoT cloud platform and display the ECG graph. Okay, for the flowchart of this project, show in the slide, uh, start from get the input, the ECG sensor, then we split into two types of microcontroller, Arduino Uno and ESP32. For Arduino, when the ECG signal are received, it will process to the serial plotter on Arduino or processing IDE. Then we display the ECG graph. And if the Arduino cannot process, it will return to ECG sensor to get the ECG signal. Okay, for the ESP32, we'll do the same process. When ECG signal are received from ESP32, it will collect data, and then it will send the data through Wi-Fi to IoT platform, and it will display the ECG graph that collect data from the ECG signal. Okay, the hardware that I use is Arduino Uno, ESP32, and most importantly, ADX232 ECG sensor. Okay, for the Arduino, I use Arduino Uno as an open source microcontroller board to get ECG graph in serial plotter. Okay, for the ESP32 as a Wi-Fi microcontroller to send data through Wi-Fi to the IoT cloud platform. Okay, last but not least, the most important hardware or component in the success of this project to get the ECG signal is the AD8232 ECG sensor. It have three lead cable that are red electrode, yellow electrode, and green electrode. Okay, for the red electrode, can attach to the right arm or right chest. For the yellow electrode, on the left arm or left chest. For the green electrode, attached to the right leg or below the right chest. The software that I use to that I use in this project is Arduino IDE, FreeZing, and UbiDots. Arduino IDE is to get the ECG graph on the serial plotter. For the FreeZing, I used to design the schematic project. For UbiDots, UbiDots as IoT platform to get the data from the ESP32 through Wi-Fi from the ECG sensor that I use. Okay, this is a schematic project that I construct in FreeZing software. It is interface Arduino with ADX232 and interface ADX232 with EXP32. Okay, for the initial result, for this project is about to show the ECG graph by using Arduino board, ECG sensor, and ESP32. In this proposed project, it works when interface ECG sensor module ADX232 with Arduino Uno board or ESP32 Bluetooth and Wi-Fi board to get the electrocardiography ECG of a patient on the serial plotter and to Internet of Things IoT cloud platform. In my slide, this the connection prototype that I connect with ECG sensor and Arduino. So in serial plotter, it show the initial result just like that, ECG graph. Okay, next. Okay, for the expected result, we show the variety of different type of heart rhythm, such as normal sinus rhythm, arrhythmia rhythm, bradycardia, tachycardia, atrial fibrillation, ventricular fibrillation. Okay, tachycardia, elevated resting heart rate, more 100 BPM, beats per minute, and bradycardia, depressed resting heart rate, below 60 BPM. Arrhythmia, irregular heart rate, beats that are so common in young people that it is not technically considered a disease. Fibrillation, unsynchronized contraction of either atria or ventricle leading to dangerously spasmodic heart activity. Okay, for the electrical activity of the heart, the P wave represents the polarization of atria in response to signaling from the sinoatrial node, such as atrial contraction. The QRS complex represents the depolarization of ventricles, such as ventricular contraction, triggered by signal from the AV node. For the PR interval and ST segment, show between this period of electrical activity are intervals allowing for blood flow. The T-wave represents repolarization of the ventricle, such as ventricular relaxation and the completion of the heartbeat. Okay, conclusion of this project. At the end of this project, development of an IoT-based heart palpitation monitoring for heart disease patients using Arduino will be developed and proposed. This project provides an overview of prior work that is relevant to this project and may be used to generate ideas on how to enhance and complete it. This project will be carried on to the next stage, which is the hardware development for this monitoring device. Okay, this is my Gantt chart for PSM during my PSM1. Okay, thank you.